Okay, so back to the topic that related to diagnosis. Okay, so troubleshoot and diagnosis is totally two different things. Okay, in my class, troubleshoot is you see the trouble and then you do what kind of action in order to diagnosis. I mean, troubleshoot is just under the category of diagnosis. Okay, this is just one of the way. So SOP is contain a lot of stuff like this. Okay, by the way, I design my own SOP for each circuit. So this is very important that you can repair almost 90% of the things. Okay, here comes. We have a case that is very coincidence after the video, you know. So there's a dealer, he say he tried everything and cannot get the display work. And this model is iPhone 6 Plus. Okay, he only just passed me the board and the LCD. Alright, so of course my team will test the LCD, it is working, and another LCD on this board is not working, things like this. So basic things must be tested. Okay, I don't know how is this guy level, but he say try everything. Okay, so people like this, I love the challenge. Come bring to me. You know, he bring to me, it almost seems like the face is, nah, I think you need to do the CPU, huh? Transplant, huh? This kind of thing, you know, the eyes is like this, you know. He thought every job is almost like that, because this kind of guys always thought, I only need this kind of skill in order to complete my whole, I can repair everything, okay? Complete my whole training and things. This is the only skill I want to obtain. This is the only thing I don't know how to do. Okay, they are too obsessed with this kind of things. Just like the video I posted earlier, the cool term things like this is I say level 4, but I didn't mention level 5 and 6 yet, you know. But to be honest, these kind of things do not too obsessed, you know. Not only the cool term, I am saying the CPU stuff, CPU skill, RAM skill, whatever, you got it there. Okay, so this is the pyramid of all the cases in the iPhone. Okay, let's say assume it's like this, and this pyramid below there, 90% they are all can be solved by using my SOP or bunch of basic technique and knowledge. Okay, so pinnacle on the top, this kind of thing is like 1%. You just need to use that kind of method to diagnosis. Okay, but doesn't mean this is the only way to diagnosis, you know. This kind of thing is just like you have more people to agree you to do this. Let's say they are all indicated this method, SOP and thermocam, and also this whatever he is showing, all indicated has a problem. If like this, then you are proceed to do the things, because a lot of methods are agree you to do so. So the more diagnosis you have, it means like this diamond, the more dimension you got. So how many skill you can diagnosis is very important. You cannot just learn one, you know, as many as possible. Even the oscilloscope. Okay, this oscilloscope is very common too in the PC repairing field. Okay, so yeah, by the way, I'm not repairing PC. Okay, so I don't talk about oscilloscope a lot, but I keep bashing oscilloscope scan. You know, a lot of people that use oscilloscope to find a problem, but actually they are using another method to get it. Okay, a lot of scan like this. I will share this more in future video. Okay, let's back to the topic. I want to cut this short. So the guy say try everything, huh? Let's diagnosis together. By the way, I'm currently building the online videos. So one of the chapter is called initiality. Means no, it's not this one. So initiality is mean initial diagnosis. So the beginning, what you should do. Okay, let's begin. Alright, so this is the board. So first, of course, we connect the LCD, and then yeah, by the way, I let you take a look at the motherboard condition first. So I already took a look just now. So you see some flux here, and there's a missing screw mounted. Just only this thing is missing. Don't worry about it. I believe they are checking the screw hole damage. Okay, but as far as I see, no. it didn't have any screw hole damage. So means in this point, the skill is not bad. They do check, based on the experience, they do check these kind of things. Not bad. Before I directly to measure, actually I can do this very fast. I believe I can fix this kind of problem just under 1 hour. It can be done. I don't know what's wrong with it, but I believe so. If I cannot do this, I should close my fucking class. Because of teaching, that's why the time will drag a long time to explain a lot of things, a lot of details. That's why I always say, learn the rules like a pro, step by step, and then bend the rules like an artist. So I don't want to bend any rules now, so I will begin very noob ways to diagnosis. So the first thing, we should measure the LCD connector or the resistance here, alright, to make sure it's okay like this. But before we go to do that, you should always plug in the LCD and see what kind of no display he is saying about. Because no display, when he say no display, okay, no display have two types of no display issue. One is totally no display, but the backlight is still there, okay? Another one is the backlight is gone, but the display is still there. Means the display is indicated something like the LCD of the calculator like this. You need a flashlight to blow on it, and then you can see actually there's a logo when it's loading. There's some display in there, but the backlight is gone. Okay, and this method of looking at it is not valid for the OLED screen. Let's say about 10R and below, all the models are using the LCD. So LCD, they can check like this, so see which problem he got. Alright, so I will put into here. Okay, whatever is it, first SOP is read the current. So the normal phone, what the first click should be 80, and then it will go uploading like this. It will like this, not too much, few hundred of milliamp. So it wouldn't go beyond 8 or 10. That one, if that point is just a while only, that one is loading the basement. Okay, so before, when the LCD is turned on, before the phone is loading the basement, it shouldn't reach that high. So we must need to know. Okay, so now I'm going to turn on the phone. Okay, as we can see, immediately the current is load that high. Immediately, that is 500 milliamp. It is too high because it doesn't usually load this high, and we see it is totally no display at all. So what about the backlight? You see, there's a backlight. You can see the light is leaking. So when the backlight is there, let's turn this off, and you can see the backlight will be gone. Backlight gone. So in this moment, I already know something is already short, so it will make my repair easier. Okay, but in this point, we have two way to diagnosis. Okay, the class I train is commando. Okay, let's say if the technician is well equipped, he got a thermal camera, I believe he can find the problem very fast without using any SOP. But in my place, I always train the student two ways. Okay, one way is the convenience way by using the thermal camera. Immediately he can find out this issue, because anything load beyond 100 mA, 100 milliamp above, you can find it. You can find which circuit is causing the problem. Okay, that one is too fast. Okay, I want to skip this. I want to show you the second way. Okay, traditional repair method. It means we will use rosin, anything that is not so modern. So I will forbidden myself to use the thermal camera. Okay, but by the way, I'm the specialist of using thermal camera. Okay, so but I still need to teach a lot of SOP to my student. In what if one of the day he doesn't have the thermal camera? Okay, don't use thermal camera. Let's see. Okay, since it is obvious, have backlight. Backlight is working. Backlight is lighting. But only the Chestnut is not working. So what is Chestnut? Chestnut is the term name named by Apple. So Apple called the display IC as a Chestnut. Actually, this is the display PMU, you know. It means the display IC actually just responsible for supplying the power to the LCD. Okay, so any graphic, whatever image you want to display, it is the responsible from the CPU directly send this into the LCD. I will explain this in the schematic. Okay, first I'm gonna show you under the microscope. So obviously they already changed this and the problem is still the same. Yeah, for sure. So they already replaced the Chestnut. This is the Chestnut. These two are the backlight IC. If you are not familiar with this kind of thing, yeah, you can go to iFixit or whatever website and take a look at the motherboard, every chipset, what is the chipset responsible for, okay? So I'm really familiar with the iPhone. This is why I know this guy is the display IC. Display PMU, also known as Chestnut. So these two are backlight. Backlight and display, they are working separately. So you have the backlight, no need to fix anything related to the backlight at all. And by the way, first symptoms, the power supply already told us one symptom, high current. It means circuit, one of the circuit is draining the power too much. So more likely it's the display. But before I immediately measure, I have to show you that first step, you should use ZXW 6 plus. Go to here. Alright. And then look at this IC. U1501. Okay, this is the label in the schematic. So in the Chinese it says display power IC. Let's assume you don't have other software. You can click on it like this to see each pin, what is it responsible for, you know. It's easy to know it. But I don't want to do this way. Let's do in more original way, okay? So let's open the Apple schematic and iPhone 6 Plus and look for it. U1501. Go to it. Okay, so this page is Chestnut, backlight driver and Nissan boost. So there's a few IC in this page. So this one is display PMU, Chestnut. So this is why we keep calling it Chestnut, because the Apple call it so, then we call it Chestnut. So how we read the diagram, this is Apple diagram. We just need to know how many pins inside. So in looking in the ZXW, we already know is 4 times 5 is 20 pins. So in the normal school that you get from the China, they will teach you diagram things. But the way they teach the diagram is not too original, you know. If they teach in this way, maybe they will think it waste too much time to bring to you page to page like this, okay? But sometimes it is best you look at the original things, okay? Now I show you that kind of diagram. We are going to open this software Wuxingji. I'm going to log in. So inside have many information that is come from the third party, especially the repair case, how to remove the CPU things, stuff like this. You can see from here. And this is also one of the reasons a lot of schools don't want to share this into the student, because they're afraid you might not interested to their course anymore. And some of the schools limited your resource, so then you will keep coming back to their school. Okay, you will be outdated that fast. Let's say there's a new model iPhone 10 or some diagram you're gonna get, so you will keep going back to the school. So they do have a lot of school like this. I prefer to share my resource where I get it. Okay, so in here we go to the iPhone 6 and 6 Plus. They are the same, but I will go to the 6 Plus because they are using the same circuit. So there's a category. By the way, this software, they do have an English version for it. There's a category is called the body diagram, something like this. So all I need to look is the IC name. Yes, this U1501, and click on it. So this is the full diagram, but not Apple diagram. No? They draw it based on the Apple original schematic. So this kind of Mac is just telling you how many things are involved, you know.
So the middle one is the Chestnut, and this one is the display FPC, the connector itself. This is a touch IC, so this is white touch IC, black touch IC, this is the power IC, even the charging IC is there, the connector is here, yes. Yeah, this is the diagram, this is the battery connector, CPU, and that's a USB IC. I believe this is the transfer, okay.
A lot of school, when they teach, is like this. They tell you how many things involved, the power, how it comes and goes like this. But it doesn't help that much, you know. Just telling you how many things are involved. But in your brain, you might cannot absorb in that time. Even you might figure out one or two things new to you, but eventually it doesn't help at all. So literally, they are just like giving you a map. This is the city map. Okay, let's say it's New York, okay, but he doesn't give you any compass or doesn't give you any GPS location. You know, you don't know where are you. Literally, you didn't learn a thing. You know, you are just stand in the middle in nowhere. You don't know what to do. What you do in this map, okay? But of course, they will explain to you. This is the power generator. This is the telecommunication building, and yeah, this is where the people live, and like this, they explain part by part. But once the problem appears, let's say one of the area didn't get the power, so where should I check? Okay, you should check the sewer station, train station, power generator station, or where. Maybe one of it, they have a problem causing this kind of problem. You know, that's why SOP come in. Where to begin? Let's make an example. You are in the forest now, so if you have a SOP, you won't get lost because you still can look at the sun. Where's the sunset? Okay, where's the sunrise? And then you can use this east and west thing to walk the path according your map. Okay, you still can get out of the wood. So it's very important that have a SOP to let you do this, to verify each circuit whether that works or not. So this is why I very rare to read this kind of thing unless I feel something is missing. Okay, let's do the basic way. Let's back to the basic way. Since I know not much involved in the original diagram, so I just need to figure out all the bow line. So this is the source of the power. VCC main is from the motherboard power. So this IC should get the power. If he didn't get the power, it won't short at all, you know. So immediately I have to measure this all because they are the output power. They are providing the power to the LCD. Okay, and these two line is important. I will check these two. There's two capacitor. Okay, this also a capacitor, but this is special. This capacitor doesn't go to the ground. I will explain it in the ZXW, so you will be much more clear about this. Okay, these two are the I2C. They come with a one pair. They are communication to the CPU. And this is very important. LCM to Chestnut power activation. EN is mean activation. Okay, and this is a reset line. Okay, 1.8. Chestnut to PMU, which means from direct go to power IC. I don't need to search this name and go to the next page. I can know it is directly connected to the power IC, and there are the CPU, and this is to the connector, and this is reset line. Okay, all right. So not much thing to measure. Immediately begin our SOP. I will change the look into this for our easy looking. Okay, so this is the display connector. Because I'm very familiar what will go first, okay? So because they don't explain the schematic in my way, that's why will be very confusing which one to read first. Okay, the first important line is, of course, this IC need to have power to go in, okay? But it can turn on, you know. So the power is go to the L1519, and there's a capacitor here. So these two lines should have the VCC voltage. We will look at the coin condition here. So we just look at the coin condition. So this is L1519, and from what I see, it seems fine. No shaking, condition is good. Alright. Okay, now we are going to measure all the output. Okay, see what's wrong. High current, let's see whether he can produce the voltage. So there's a 5.7 pp and 5.7 for the touch, 5.7 the LCD, and PN is negative of 5.7. Okay, we just check this few line. So this is the LCD connector. I explain here some of the things here. So you will see a lot of coin like this. A lot of coin like this inside the glue. They are directly communicate with the CPU. They are responsible to sending the image. So they are not related to the high current. So I don't need to check this. Until I fix the current issue and it's still no display, I will check it in here. So this online, I don't check at all because they are the CPU sending image to the connector. This all, you don't need to check. So the first thing I check is 1.8 LCM. So the 1.8 is directly supplied from a power IC. So when I click on it, zoom out, you will see this 1.8 is sharing a lot of places. It is come from the power IC into the connector here. It means the LCD need a basic power which is 1.8. So why the LCD need a 1.8? Isn't the LCD is a high voltage things? 5.7, 5.1, I don't see the 1.8 equal to the LCD. Okay, so there's a reason for this. So how the LCD will tell, by the way, a lot of people that don't know that the Chestnut doesn't work if their LCD is not connected. So mean if you don't connect the LCD, the 5.7, 5.1 stuff, they don't even bother to produce. Okay, they don't even to supply. So you don't get any measurement of wattage in there. So this is why he get the 1.8 power from the power IC. And then the LCD got the power, he will transfer back the 1.8 back to the Chestnut. So this is why he say LCM to Chestnut power activation. So it is, okay, this line. So this line is responsible to tell the Chestnut to be working. So he is kind of like first priority. So make sure you got a 1.8 and also got this. But I'm fixing the high current stuff, you know, something short. So I believe this line should be fine. So let's randomly to measure this all. The CPU connection I don't need. So I will need this resistance
to be working. Okay, here, 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 here. They are all have a resistance. They are fine. So this one is empty, OL is normal. Blue one, and this one OL is normal. So we are kind of going to the backlight section. They are all okay. So to measure resistance is easy. Just do this. So everyone is ground is ground, resistance is resistance, everyone seems normal. Yeah, nothing, no surprise, you know, they say they try everything, it must be, the problem is not normal. So none of them seems short.
Let's see the output. So plug in the LCD. I don't want to do that 1.8 jumper to fool the Chestnut and then measure. Just directly plug in this kind of stuff. Yeah, by the way, I have to show you that the current. So turn on. Okay, so the phone is turning on now. Immediately flip it over because I'm going to measure the things behind. Okay, so I need to know few things. Immediately I have to check the 6.0 whether they have enough power for himself. Okay, alright, don't have. They are only producing 3 point something, 2.9. Okay, it is not working. So let's say 5.7. So not reaching 5.7. Alright, so I look at behind here, let's see. PN 5.7 I don't get. We can see they changed the touch IC. Touch IC is hot. They replace the touch IC. So maybe there's something wrong with touch IC also. Okay, they also make the jumper, as we can see. Alright. So without using thermal camera, we also need to touch the things one by one. No, the Chestnut is very hot. For sure, it is one of the problems.
Immediately we begin to remove the Chestnut. We don't replace the IC without applying SOP, okay? Now all I do is just take it out and measure. So it has been removed before, it should be easy. Alright. So put aside first. Remember the first pin and then put aside.
So cool down the board first. Alright, so continue to measure the resistance. Make sure OL stay OL, ground stay ground. Okay, so now begin to check resistance.
Correct, go to the ground and then begin. OL say OL. They are OL. This is also OL. Okay? But from what I'm looking at, these two lines can measure. You know, PN doesn't mean OL. So he goes to the connector here, seems like nothing, right? But actually he also supplied the power behind here. The touch IC. That's why when you reverse to measure, it will have resistance. So reverse means black put to the ground and then the red put to here. So means that is okay. Touch IC is fine. It is connected. So the number 4 here, 196. Ground 418, 419. OL 600 something. 366. Ground 326. OL 397. OL, okay, 500. Okay, yeah, they all have. So
if they already replaced the display IC and it still doesn't work, means it's still the circuit problem. Okay, so when the IC itself get hot, it is the some of the capacitor responsible for this IC, especially the one who store the power. You know, if it is not working, it will causing the IC to be overstressed. You know, the IC will become hot. Okay, I tell you why in the schematic. So who is responsible for the IC to store the power? So let's say this IC, he got two packs, he got two capacitors, he's storing the 6.0 for himself, okay? And also there's another capacitor in here, okay? But this one is coupling, you know. So you have to check whether they are short or not, you know. The most common repair in an iPhone is the capacitor field itself. Immediately use this ZXW to check that two line. So this is the B3 and B4 LCM boots. B3, B4, these two. They are OL. They didn't short, okay? But you don't know whether this line is connected to the capacitor or not, you know, they are not nearby. That's why you need to flip to the other side in here. So which is here. But I know it is connected because when I measure it, it still got about 3 watt. So this is why they are connected. I have to just make sure one side is the ground, one side is not short. One side is the ground, one side is not short. So this is a coupling here. So this line is the one in here. So C1554. So if you measure like this, you won't get anything because none of them two side is not ground. So no point you to measure the resistance like this. So I already locked down my problem because a lot of people, they, especially the guy without training, they don't know how to measure the coupling. You know. Coupling, they do have their own SOP to check. If I use this way, check all the capacitor, they should stay in OL. If there's some value come out, mean it is punctured, half short. Okay, so now I measure this, it's either half short or full short. Okay, something wrong. Let's press it harder again. See, it is 230 something. Something is there. It shouldn't come out any value at all. So mean it is puncture. I also call it half shot. So in my area we call it half shot. Some of the Western guy they'll call partially short. So this cap have a problem. I believe once I replace this, problem will be gone. You don't remove this, you know. Because encoding our schematic, there's only one capacitor is linking to each other. So it is very important. You must need to replace it back. So I believe when I replace this, the problem will be gone. But let's put back the IC. This time, I will verify my troubleshooting is correct or not by using the thermal camera to verify again. As I say, the more side you can verify the issue, the more better. Okay, so put back.
In a condition like this, I don't reboil. I just put back exactly where it was. It should be fine.
Let's cool down the board. Alright, so put it back. It should not be fixed yet. You still need to fix the gap, you know. Look at the power current again. So turn it on. Okay, turn on already. Now we are recording. Okay, now we are looking at the Chestnut here. So Chestnut get very hot. CPU is loading, it is fine. So Chestnut is reaching 60 Celsius. I think I will cut the thermal camera scenes in this episode, okay? I will put into the thermal camera class there. Because there is some other setting you need to know about the thermal camera. So let's begin the repair. The NFC IC is right beside here. So let's do the final checking. If I use buzzering mode, I measure this guy and it come up with value. It's not normal. So now I look at the board. So I take another board that I can take the capacitor. Okay, this is the same location of the capacitor itself. So when you measure like this, nothing. Okay. When you go to the dial mode, it shouldn't give you anything at all. Okay, like this. This is totally zero well. So when you come back to this guy, when you put like this, you see the dial reading is give you 0.100. So it is punctual. Take him off. Carefully borrow the strength of the IC, and then like this. Okay. Of course, we shouldn't use this way to remove it, because I forgot this is not the VCC cap. That this guy, I need to replace it back. Wow, both of them is broken. It's idiot. So now I kind of like fuck up. I need to do the jumper. But never mind, just verify the problem first. So yeah, this is the problem for sure. Let's puncture. Go to my trophy. You just find a compatible capacitor, okay? You can take exactly the same one. Just in case, let's say you don't have this kind of capacitor, you can look in here in the schematic. So let's say this is a 10 UF, okay? It's a 10 voltage, okay? This is the material and the size, okay? Ceramic. So it's made by something ceramic. So 20% means it can be do 20% up and down based on this kind of setting. And 10 voltage more important. It can do the job that is below 10 volt. Okay, so do not use randomly whatever you can find. Let's say this type of capacitor, it is not allowed to put in there. You see, he is responsible for 6.3 volt like this only. So you have to take the same one, 20%, 10 volt, and this kind of size. So that's by using the DXW, you can see every spec of capacitor is right in here. You just point to there and then you look for similar. This one is not suitable, 6.3. This one is suitable. It's exactly the same. So just take whichever you have.
So take this aside. I have to prepare the capacitor first. You can take this or take this, they are the same spec. Let's put aside first, stick to here. Begin the repair. It's too idiot to remove like that way. You should use heat to remove, because I've done this too many times. The habit of removing VCC can, things like this, is my daily job. That's why I remove like that way, and eventually got myself into here. So yeah, I guess I have to fix these two parts.
Alright, So make sure that both have resistance, because the resistance come from the chestnut itself. So when you have to measure something like this small, you have to add a blade like this. Okay. And then plus like this. So you see 613, and this is okay, 1900. It's normal it's high like this because should be the negative line. I didn't check in the schematic, but I can show you. So let's put in the reverse. So the rate on that, if you don't get the low value, you will have a problem. Okay, so it's 615 now. So the other one should become high because it is the negative line. All right, so now we are going to do the jumper.
Seems pretty, but it is fine as long as it's working. When I check these two sides of the cap, they should have resistance. Okay, one high, one low, unless I reverse measuring. Okay. Okay, got it. 615. Here should be 1000 something. Unless, okay, let me check again. 1900. Reverse measuring. 600 something. And here is 1000. Yes. Okay, so now the exciting time is to put on the screen and then see whether the screen works or not, display come back or not. Okay.
Okay, so take a look in no point if the current is not fixed. Okay, so let's take it on. So when I turn it on, you see the current is not above 500 milliamp anymore, and do not expect you have the thermal camera and you can do everything, you know. You still need to understand the circuit, how it works, you know, which one to use what method, especially the coupling, OL stuff, a lot of things. That's why I keep saying, you just know how to measure resistance, but do you know the resistance logic? I have 10 scenarios. This is just one of it. One of the scenario, the case will be like this. You know, some of the guys, they even go to transplant the board. They will move the CPU into the other board because they cannot find the problem. So, see? Display is back. In case you can't see, I will just press on there. Okay, there. So even the touch IC, I didn't mess up with the touch IC. So the touch is working. So this is how we take the money. Okay. So seems like some important information in here. Alright, so let's look at the things I done. It is here. Okay. So did I replace any IC? No. But I do replace the cap. I will put more interesting case in future. Bye.